about the mole, and it's not any kind of these moles. By the end of this video, you should be able to describe a mole, calculate the molar mass of aluminum phosphate, and calculate the percent composition of methanol. You need to get a calculator and a periodic table, so run go get that. Okay, so a mole is not a little fuzzy animal or a thing on your face. It's a counting unit, like a dozen is 12, a pair is 2. Well, a mole is 602 billion trillion, or 602 23 zeros, okay? You write it like this in scientific notation, because it's just easier. And when you put it in on your calculator, don't forget that times 10 is like hitting the exponent button. This is Avogadro's number, 6.02 times 10 to the 23rd. It's named in honor of Avogadro, okay, not avocado. I don't remember how he figured out this number, but he did, and that's good because now I don't have to do it. So just how big is a mole? Okay, well, if we were to take soft drink cans to cover the surface of the earth, it would be covered 200 miles deep. Or if we had 6.02 times 10 to the 23rd unpopped popcorn kernels and spread them across the US would be covered in 9 miles worth of popcorn kernels. And if you're going to try and count atoms, a mole of atoms, and you could count them at 10 million per second, it would still take you 2 billion years to count the atoms in a mole. So a mole is huge. Okay, so a mole of anything contains this number of particles. A mole of carbon contains 6.02 times 10 to the 23rd carbon atoms. A mole of water contains 6.02 times 10 to the 23rd water molecules, and so on. Molar mass. This is the mass in grams of 1 mole, and it's equal to the mass on the periodic table. So 1 mole of carbon atoms is 12 grams. 1 mole of magnesium atoms, 24.3 grams. So you can thank Avogadro for doing this conversion for you, because now you don't have to do it. You can just look at the periodic table. Other names, sometimes it's called molecular mass, molecular weight, formula mass, formula weight. It's all the same. It's all molar mass. They all mean the same thing. So don't freak out. Okay, so how do we calculate molar mass? Well, you just add up the mass of each element in your molecule. So 1 mole of salt, I've got sodium, and 1 mole of sodium weighs 22.99 grams, and chlorine weighs 35.45 grams. So I'm just going to add those two together, and I'm not doing this in my head this time. I get 58.45 grams. Oops, 544 grams per mole. So this is the molar mass of sodium chloride. So 1 mole of water, well, I've got hydrogen, which is 1.008, but I've got 2 of them, right? So I'm just going to multiply that by 2, plus my oxygen, which is 16. So 1.008 times 2 plus 16 gives me a molar mass of 18.16 grams per mole. Okay. Alright, solving mole problems with dimensional analysis. These are the steps. I hope y'all remember dimensional analysis from the beginning of the year. So you're going to start with your given, set up your conversion factors so that your units cancel out, multiply across the top, and divide by what's on the bottom. Everything has to go through moles. So if we're trying to go from grams to moles, we're going to use molar mass. If we're going from moles to particles, we're going to use Avogadro's number. Alright, so aluminum is often used for the structure of lightweight bicycle frames. How many grams of aluminum are in 3 moles of aluminum? Well, I start with my 3 moles of aluminum because that's my given. And I know by looking at the periodic table that in 1 mole of aluminum there is 26.9 20.8 grams. 20.9 grams. Okay, so my moles cancel out, and then I just multiply across the top, divide by what's on the bottom, and I get 80.94 grams per mole. Whoops, just grams, sorry. Alright, and look back at your sig figs. I have 3 sig figs here, so I need 3 sig figs here. So 80.9 grams of aluminum is my answer. How many atoms of copper are present in 35.4 grams of copper? Well, I'm going to start with my given. And I want to go to atoms. So first I have to go from grams to moles, and then moles to particles. Or particles could be atoms, ions, molecules. Anytime it says one of those things, you got to use Avogadro's number. Okay, so I know from the periodic table that there are 63.55 grams of copper in 1 mole of copper. So my grams cancel. I also know that Avogadro's number in 1 mole, there is 6.02 times 10 to the 23rd atoms. Okay, so my moles cancel. Now I'm going to multiply across the top. Times 10 to the 3rd, and divide by what's on the bottom. Oops. Okay, and I got 3.315. I only need 3 sig figs, so 3.32 times 10 to the 23rd atoms of copper. Okay. All right, percent composition. Super simple. First you find the molar mass of the compound, multiply it by the numbers of atoms in that particular compound, and divide by the molar mass. So it's kind of like figuring out like your grade. So here I've got 2 carbons, 2 carbons, and 1 carbon weighs 12.01, so 24.02 plus, I have 6 hydrogen times 1 point, I'm just going to round to 101, gives me 6.06, and I've got 4 oxygen, so 4 times 16, I want to say that's 64, I better put it in my calculator. It is 64. Okay, so then I just add all those up. And I get 94.08. This is my molar mass. Okay, but I want to know the percent of each. Well, I'm going to take 24.02 and divide it by my molar mass. I get 0.255, so times 100, and I get 25.5% carbon, and then 6.06 divided by 9.08. I need to erase this. Ooh. Write that down here. 94.08. Okay, 6.06 divided by 94.08 times 100 gives me 6.44% hydrogen, and then 64 divided by 94.08 gives me, times 100, 68% oxygen. And that's it. Alright, if you can't answer the questions at the beginning of the presentation, then watch it again. I also put up a practice video where I just work problems for y'all if you need that.